Hi, Kip. This is Santi. Thank you very much for all your help. I really appreciate it. I just want you to know that without your help, I wouldn't be doing this right now. So thank you very much. I appreciate it. I'm about to give you a presentation. I want you to look at it and maybe tell me where are the things that I might have to change or work on before I go. So today's Friday. For me, I have about a week to work on next week about my presentation. And I really want to win. I really want to win. In fact, I think I told you that we're 5 this year. And one of them, the one coming from UK, is actually really strong. Really, really, really strong. So I want to give my best try. I want to do my best. It's simply the only thing I can do. I do not have my box, but I'm going to do something else. I just wanted to show you afterwards like what would be my box. I don't have my box right here. So just imagine that this will be my box just for this presentation. So this is my box. Ladies and gentlemen, how many people do I have in the audience today that know what's happening in outer space? Sadly, I have very bad news to tell you today. Because Aphobis is a 300-meter asteroid that is moving at 14 kilometers per second and is coming really close to the Earth in 2036. So what are you doing on March 22nd, 2036? Well, mark in your calendars because that's the day we might get hit by this killer rock. So, sir, unfortunately, you might not make it with your boss to that meeting with your boss that day. I'm sorry. But what if a software could help us predict the probability of collision between a killer rock and the Earth? Would that be beneficial to us? My name is Santi, I am from Canada, and today I will present you simulated asteroids, detection and analysis. This presentation will begin with a brief overview about today's challenges in asteroid research, and then we will follow up the design process of the system development. So here is a picture of our solar system. I want you to notice that those red points you see on the screen are actually dangerous asteroids. So in fact, the Earth is in a real awful position. Those green points you see on the screen are a cloud of asteroids between Mars and Jupiter, and you might think that, okay, they're not a threat to us because they're green, but in fact, some of them are a threat. It's just we simply don't know they're a threat because we haven't analyzed them yet. This is the visual problem. On a conceptual level, asteroid research is facing 2 main challenges. One of them is that telescopes are getting more sophisticated, and the other challenge comes from a budget point of view. So telescopes are getting better, they're taking more pictures of the sky, and therefore the discoveries are increasing exponentially. Currently, we have too many data acquisition technologies, such as telescopes, such as radio telescopes, but not enough data analysis technologies, such as simulators. Therefore, the objective of this project is to provide a reliable and both time cost sensitive analysis system that could digest and process all the information given by our telescopes. This system is divided into 3 steps, with the main focus on the analysis part, not on the hardware, not on any deflection techniques, just on the analysis. So here is the design process. As you could see, the first step is the pattern recognition. Here, we are going to discover the asteroid. Once we have discovered the asteroid, we want to know how far is it moving, we want to know where is it going, and all these questions are going to be answered by the physical simulator, which is the second step. Finally, the analysis part will be done simultaneously with the physical simulator. The question we're trying to answer here is how dangerous it is as it gets closer to our planet or further away. So the first step mentioned is the pattern recognition. So telescopes are going to send us pictures of the sky. We're going to compare those pictures and try to identify if from one picture to the other one there is an object that is moving. Notice, however, how difficult and expensive it is to test and design such a software. All the logics in the method implemented by sophisticated softwares make it difficult to test, read, and debug, and therefore making this type of research unavailable for smaller research agencies. It would be nice if we could implement a mechanism that will look for asteroids in an automatic way, but also look for asteroids in a simpler way. Would that be possible? And the answer is yes. This is the system proposed. And you could see that not only will look for asteroids in an automatic way, but also all the images that contain high-level noise given by our telescopes are going to be cleaned for further analysis. So once the discovery part is done, which is the pattern recognition, we want to know many things about this asteroid. We want to know how fast it's moving, we want to know where is it going, and all these questions are going to be answered in the physical simulator. So the physical simulator looks like this, and it's original because it's easy to implement. You don't need a PhD, you don't need to program to use the software. It's a fast simulation, which gives the user a quick overview of where is the asteroid going exactly. Finally, and more importantly, it's innovative. So let's consider a simple case scenario. Let's consider the case scenario where we in fact have a collision between the asteroid and the Earth. And let's see what the system can tell us. So here is the system at work. And you could see right away that there is a table that will tell the user how the distance between the coming asteroid and the Earth changes over time. What will be the next velocity of the asteroid? What will be the next acceleration of the asteroid as it gets closer to us or further away? Secondly, is the orbit diagramming, which is essential in asteroid research, is being able to see where is the asteroid going. Finally, is the probability of collision, which is on the bottom of the screen. And because this asteroid is close to the Earth, and because the velocity of this asteroid is pointing towards the Earth, the probability of collision is quite high, which is 80% in this case. So we're going to get hit by this asteroid. To understand how this system works and how the probability is established, let's consider a simple case. Let's consider the example where we want to know if you are a rich person. So there are two ways to know this. One of them is to look at your net income account. But unfortunately, we do not have access at your net income account. So we could probably figure out something depending on where you live. So let's go to your neighborhood and let's see how many rich neighbors you have around you and how close you are to those rich neighbors. Therefore, we could determine a probability of you being rich. In a similar context, this project is going to use the so-called nearest neighbor method in computer science. So let's assume that this is our neighborhood, the Earth is in the middle, and those things you see around the Earth are asteroids. Well, do not worry, because in real life, they're much further away from the Earth. This is just an example. So this is our neighborhood. Once step one is completed, which is finding the asteroid, discovering the asteroid, we want to input the unknown asteroid and determine how dangerous it is. That's what we want to know. So you're going to input the dangerous asteroid into the system. But because we know right now which asteroids are a potential threat to us, we could denote those dangerous asteroids by red triangles. So the red triangles are dangerous asteroid we have statistics for. So once we want to know the dangerous, if we want to know the unknown asteroid, how dangerous it is, we want to input the unknown asteroid into the system. We're going to compare it with near asteroid neighbors. So in this case, because we're close to two non-threatening asteroids, the probability of being dangerous at this point is pretty low. But asteroids move, and in fact they move pretty fast. So when they move to a new position, new neighbors have to be taken into account. So in this case, when new neighbors are taken into account, we could see that we are close to 3 threatening asteroids, and therefore the probability of this unknown asteroid of being dangerous is much higher. And this is done not only with respect to the position of the asteroid, but also with respect to the velocity of the asteroid. So we are looking for 2 things in order to determine how dangerous it is. There is a clear need in asteroid research for data analysis system. We have too much data and we don't know what to do with it. The proposed system not only is a quicker and inexpensive analysis system, but also is innovative because we're able to see where the asteroid is going, and because the system tells us how dangerous is the asteroid as it gets closer to us or further away. Ladies and gentlemen, do you see this rock right here? You probably don't see it because it's so small that it's not a threat to us. But imagine a rock like this one, but 2,000 times bigger. Then it would be a problem. Thanks for listening. Alright, I know how to work on it. That was it for today.